Hey everybody, I just wanted to touch base with everybody. It's been a while since I posted. I've been entirely preoccupied with mazes, and I had posted some stuff about mazes before. Well, I just went ahead tonight and kind of did some function creating, or class making. I actually made a class and some functions obviously that go with that. So, excuse me, make a long story short, the maze class features a shader program, which I don't think is ever used in the maze itself, in the maze class. Anyways, start x, start y, cell size, this boolean array, the GLU int array, and the point vertices array. So the boolean array keeps track of north, south, east, and west walls, and see, is it the binary tree or Dijkstra's algorithm that it uses the visited? Anyways, keeps track of those things we need to keep track of throughout the creation of the maze and the walls and all that fun stuff. This keeps track of your point sprite colors. This keeps track of the vertices for the point sprite colors for copying into the master VAO for OpenGL, because I'm not going to use a separate VAO, VBO, and all that for each maze. We're just going to copy the point sprites that take care of the insides of the cells, basically what the floor of the cell looks like, if you will, if you're looking at it from a top-down point of view. And then, of course, we have our initialization function, which is right here. It uses the start x offset, start y offset, which are floats. They're in OpenGL normalized coordinates, and you just tell it where to start. The cell size, which is just used for calculation. It's already determined inside the Vertex shader. I will show you. It is already determined inside the Vertex shader. GL point size is 9. The cell count, so you can vary it. You can make the mazes whatever you want. I've chosen to do 35 by 25, and all I had to do was send it to the initialization function. I will show you shortly. Basically, the initialization function does everything. It initializes the point sprite colors to random, which is where I wanted them to be at the beginning. Run binary tree to create the maze wall structures. Here's where we initialize everything before we do any of that. And then it clears the north and the east wall. You might be familiar with binary tree algorithm since I used it before. Binary tree actual algorithm. For each cell, chooses north or east, which is why we were clearing the north and east hallways. Binary tree is completed. It's actually quite simple. And then we run Dijkstra's and create a color gradient, which is where we start. I just had to change the variable names, pretty much copied and pasted the code. Sets up the frontiers and iterates through them all until it's done with the maze. Changes the colors in the vertices array, but all it does is change the shading of the colors. And then, which I haven't done yet, which I'm going to and I'm kind of excited about, is drawing the walls and copying the lines to the master VAO and VBO. So then we'll have a separate lines VAO and VBO, which right now we're just using. Here's the init function itself for the main part of the program. This is where all the mazes are created. There are 15. See, I goes from 0 to 4. J goes from 0 to 2. Blah, blah, blah. VAOs, points. Copy each maze into the master. This was a little bit tricky to get the indices to work, but basically the instantiation of the classes and the init function creates the mazes within each class, and then this iterates through all of those and copies to this master point vertices from each maze. So I know there's an easier way to do that too. We're going to explore that a little bit later, but not right now. I just wanted to get it done. And then this puts the master point vertices into the vertex buffer, sets the vertex attributes. Here's where we draw behind the points. VAO, draw all the points, the point sprites. And here's what it looks like. Boom. See, we get 15 mazes, each 35 by 25, and then it iterates through and it shades the colors that are all random and bright, and it gives them varying shades of darkness to bright based on the Dijkstra's algorithm. Okay. Well, thanks for tuning in. We're going to, like I said, we're going to put the lines up so that we can actually see the walls of the maze and make sure that the shading is working correctly. And then we're going to start implementing a few more algorithms for mazes. I realize I've kind of veered off the path of doing my video game, but we're totally fine with that, and we're going to get back to the video game. If not, we're going to do the video game concurrently, step by step, with the mazes and possibly other artificial intelligence things, including flocking and swarming and things like that that I want to get into. So I just wanted to post this video to keep you all aware of what I'm up to, that I'm not just like hiding and freaking out or something. But I've been known to do that from time to time, but not right now. And tonight I did some programming. I figured out this class thing. I did this all tonight, which has been fun because it actually worked out really great, which is why I'm excited to get into the walls thing, which I've got the work that I did 2 days ago or yesterday. Yeah, the wall vertices. I got it close. And then I ran into some trouble, and then I fixed it, and then I ran into some more trouble, and I fixed it, ran into more trouble and fixed it. You know how it works. So anyways, I got that really close. We're going to get the walls working, and then we're going to copy just enough vertices to OpenGL's master line VAO to draw the lines for the walls on the screen, which is going to be so cool when it's done. And then we'll play around with the colors for the walls too. Anyways, thanks for watching. Be sure to like and subscribe. Stay tuned for more, and there will be a lot more. So